let me ask again. Do any of you have any questions, issues, concerns, problems, anything you want to bring up before we get going in class today?
So I have a quick question.
Okay.
So I just wanted to make sure, so we just have test 1, 2, and 3, and then the final.
Okay. Yes. Okay, wait. Let me get Bennett in here so he can hear the answer, both the question and the answer. Let me get, okay, Bennett is right above the blue line. There you go. Okay. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And, well, we lost somebody. Or maybe Bennett, oh, he's here. Okay, evidently someone who was here is no longer. I believe it may be Sharika. Hopefully she'll be back. Okay, here she is. She's coming back right now. So there she comes. Okay, Sharika's back. So we got 11 now. All right. The question was about, well, let me wait till Bennett gets connected to audio. I know he's trying, but it's giving him difficulty, it seems. Bennett, can you hear me? I guess not. Okay. Sorry about the delay here. I would go on and make other announcements, but I want everybody to be able to hear those too. And Bennett's still not able to connect to audio. Okay. I guess I'll go on and answer the question. Okay. Test 1 was the first half of chapter 4. Test 2 was the second half of chapter 4. That was the graphing one. Test 3 was the chapter 5 test that we had I gave you before Thanksgiving. And what we're going to do is continue in chapter 6 today. Okay, I just had a very loud noise. I don't know what that was. Okay. I don't know if someone's doing a chat or something like that, but nothing's showing up. So anyway, we're in section 6.1 today. We'll hopefully get into 6.2 tomorrow. Before the end of the day. And then we'll have the final exam. Now the final exam, excuse me. Sorry. The sun has quit coming in the window and the room's cooling off. Okay. The final exam will have 1 or 2 questions from chapter 6 in it. That will be the only testing. Okay, Bennett is trying to get back in. So let me see if I can let him back in. He's connecting to audio and then coming in by different means, but still not in here yet that I can tell. Bennett, are you here? Oh, yeah. Can you hear me? Okay, I see your microphone flash on and off, but I can't hear you. I've got 2 Bennett. You can hear me. Okay. Your other one's still trying to connect to audio. You're on here twice, but that's perfectly fine with me. Okay.
Oh, my bad. I don't even know.
That's
it wouldn't load on the application on my computer, so I
right.
do it on the browser. I don't
Right.
really know what happened.
Okay. I don't know what's happening either. It seems like the ether space has been weird all week long. Okay, so Karen, my wife, thinks it's because everybody's doing their Christmas shopping online right now this week. So I don't know if that's true or not, but I don't think the system can handle it. But anyway, that's it. Okay, so the question was about the test. The first test was the first half of chapter 4. Second test was the second half of chapter 4. That was the graphing test. The third test was on chapter 5, which you got before Thanksgiving. And then the last test you have will be the final exam. Now we're in chapter 6 now, and the final exam will have a couple of questions from chapter 6. So that's going to be, there won't be a separate test for chapter 6, but the final exam, which is comprehensive on all 3 chapters covering all 4 tests, though we only had 3 tests, the Chapter 6 questions on the final will count for your evaluation of Chapter 6, you might say. So yes, that's all we've got. Your research paper cannot be dropped. Then the 3 tests, one of those, if you need for it to, can be dropped, okay, if it helps your average. The final exam, which I'll be giving you sometime probably between 1 and 3 o'clock today, at the end of class, I'll show you what it looks like. I'll show you the questions that you should be able to do, and if any of them are optional, I'll wipe those out. I mean, I'll let you know which ones you don't have to do. Okay? Does that answer your question? Who was it that asked? Was it Kelly? Okay. All right. Good deal. Okay. I thought I had emailed that to you too, but evidently it didn't go through. Okay. Now, let's talk about wrapping up the term. I know that's in everybody's mind now. Number 1, please do your student course evaluations. They told us last week, Thanksgiving week, we had meetings Monday, Tuesday, and Wednesday. They told us in one of either Monday or Tuesday in one of those meetings, and I saw it actually on my emails, they had finally gotten the student course evaluations posted. Okay, they sent it as an email, and they didn't call it student course evaluations. They called it surveys. Most of the time they call it student course evaluations. I don't think they used the name of it. Maybe they did. They're called SMART Evals. SMARTEVALS. SMART Evals. Written as one word. It's the company name. Okay. They've been posted, and as far as I know, the way that you can access them is through that email. Now the trouble is they didn't send that email to faculty. They sent us an email later saying we have posted the SMART Evals or the surveys to students. Please encourage them to get it done. And then they had all the classes we had. So I didn't see your email, so I can't tell you what's in it. Okay? You didn't see my email, so you can't tell me what's in mine, but I can see mine. So I think all the instructions are there. Now in one of my classes yesterday, a very good student who is always on top of things said, I didn't get them. So we started looking into it, and I don't know this for a fact, but I think the problem was they only sent it to the new email that you have that is your A number. Okay? I don't think they sent it to your preferred email. I don't think they sent it to the old email that we had under the Alliance system. You know, when it was first initial, last name. Let me get Keelan in here. Hold on just a moment. Keelan is coming in the waiting room right now, or from the waiting room right now. Let me see if I can find him. There he is, right below the blue line. Got it. Okay. So, if you haven't seen your surveys, they're calling them now, go to your email and don't just check the one you normally do, check them all. You should have, many of you have maybe 3 or more emails, okay? You have the old Lawson email that was your first initial, last name, and the last 4 digit of your old ID number. That was the old one. The new one I think is something to do with your A number. Maybe that's all it is, okay? And then the others of you may have a preferred email, which is your personal email. I don't know which way they sent them. I think it was through the A number one. But check all your emails. Don't forget to do that. Those student course evaluations or surveys are very, very, very important to us. Now, if any of you took a first mini-term course, and I know at least one of you did, okay, because it was my course, okay, but if any of you took a first mini-term course, please go back and do that one, because they did not have the surveys or the student course evaluations open during the at the end of the first mini term, so you couldn't do your survey then. So hopefully you can remember enough about it to do a good survey on that one as well. Okay, so do the student course evaluations. Number 2, research papers are due in today. Many of you have turned them in already. Fantastic. If you haven't submitted them, please get them in today if at all possible. Today and in the month of December, you just get your score. If you turn it in tomorrow or later, you start losing points. So please get your the research papers in today if possible, or as soon as possible thereafter, so you don't lose any more points. Okay. Now, old test we talked about. Test 1, Test 2, Test 3 have all been out there. Test 1 and 2 have been out there a long time. Test 3 was put out there before Thanksgiving. So please get all those tests in as soon as you can. Just as soon as you can. Now, timeout, caveat. I'm really way behind in printing and grading. I've been trying recently to get caught up, and I'm catching up, but it's been a long, slow process. That month that I didn't know it at the time. I just knew I was not feeling well, having chest pains, having shortness of breath, all that kind of stuff, for an entire month, or 4 weeks anyway, more than 4 weeks. I just got way behind in printing and grading, and I'm trying to get caught up now. So hopefully I can continue the process of getting caught up. I'm feeling much better now. Still anemic, but not nearly as anemic as I was before. So I'm working at getting caught up. Y'all get caught up as well. Get me as much as you can, as soon as you can. And then, like I said, at the end of class today, I'll show you your final exam. I'll tell you which questions to answer and which do not. And sometime between 1 and 3, I'll try to get those posted. Okay? Because it's, there may be some questions on there we don't get to cover in class today. So I'll let you know that. Now, when is your final due? Technically, I think they would like for it to be in by Tuesday. I see no real reason to push it. Get it in anytime next week. Anytime next week. With one exception. Are any of you graduating this term? Anybody? Okay, if not, that's good. I mean, that's fine. If any of you were graduating this term, yours have to be in sooner. Okay, I don't know exactly what day, and unless they've told you when grades are due, I'm guessing it would probably be Wednesday or Thursday of next week that your grades have to be in. So that means you have to get me in. Now, Damien just came in. Let me get him marked present. Okay, turning out to be a fairly well attended class today. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And, oh, there are 14 students. Oh, yeah, Bennett's here twice. Okay, so that's where that came from. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Bennett here twice would be 14. Got it. All right. How do you turn in things? That's been a question I've been asked. You can turn in your research paper, your test, whatever you're turning in. Do it either by attachment to an email. That's perfectly fine. An attachment to a Blackboard message. That's perfectly fine. Or the research papers I have now put on this week, which is week 15. I opened up one of the assessment things and renamed it research paper. So if you want to turn it in that way, you certainly can. You don't have to. I just did it because some students seem to like to do that. It seems like it's more work to turn it in that way, but if you like doing that, you certainly can. but Blackboard message or email is perfectly fine. Your final exam, same deal. One of the last tabs in your Blackboard's, whatever they call that, starts with a C page, content page. The Blackboard content page, one of the last tabs in it says exams, midterms, and final. Well, we didn't have a midterm exam. All the other tests were in the middle of the term, so they were midterm, but I didn't put anything there. But deleted most of the things that were there, but I did put a place there that you can either, and if I can, I'll post the final there if they left me a little plus sign. If they didn't leave me a plus sign, I can't post there. But if you want to turn it in through that tab, you certainly can. I don't know why you would want to, but it's certainly an option, so you can do your final exam that way too. Same thing on the test. You can turn it in any of the tests, email, Blackboard message, or if there is a tab in that week when I pass it out to you, you can turn it in through those tabs. I'll be checking all three of those locations for everything that we've had. All right. Any other questions? For people who got here a little later, please do the student course evaluations. They finally got them open sometime, I think last week, the Thanksgiving week when y'all weren't around. They may have actually opened them for y'all the week before. I don't know. We got the message last week. But they may have given you the message earlier. All right. Any questions? All right. And by the way, just as a side note, this is my last full day of teaching, okay? Which means I have 4 classes a day, got 1 done. This is the second one. I have 2 more to go. Next week, I have 1 day for my mini-term 2 class. We do have class on Tuesday, but other than that, I will not be teaching. Now, if y'all want me to, or oh, here comes Courtney. Let me get Courtney here. If you either want me to or need me to have one or both of the days open next week, I can set up a Zoom for one or both of the days, Tuesday or Thursday, 10 to 11:15, just like normal. That's if you have questions, if you have issues, concerns, whatever, I can do that. But if you don't let me know that, I won't be doing that. But I will be here in the office all week long, grading papers like crazy, entering things on Blackboard, stuff like that. So I'll be here in the office. You can send me emails. You can send me Blackboard messages. You can, communicate however you want to communicate with me, but you can get in touch. But if you want to have that as an option of having either Tuesday or Thursday or both as Zoom days as well, I can have a Zoom sitting here open and I'll be working away, and if anyone comes in, we can do it. Does anyone want a Zoom either on Tuesday or Thursday? Let me know now. Anyone?
Would you have everything graded by then? Because that's the main reason that I would want to talk to you.
Well, now, I can't say if I'll have everything graded, because it may not be I'll have everything turned in by then, because you got all week to turn in your finals, so I can't possibly say I have everything graded if I haven't even received it.
Well then, I wouldn't know if I would need to get in touch with you then, because the only thing I would want to ask about would be my grades.
Okay, well, I can have it open in case you want to ask that question, or you can always email me or send me a message on Blackboard.
All right.
Okay? Will that do for you?
Yes, sir.
Okay. Any other questions? Anyone else want to open? So unless I hear from you that you do want a Zoom, and you can email me and say, hey, I would like a Zoom Tuesday or Thursday or both, let me know and we'll do it. Okay. So finally got all that done, I hope. If you have any more questions come up, please let me know. Okay?
What did you say about the research paper?
Okay. What about it?
What did you say about it?
Okay.
I caught the part about
Okay.
losing points. When is it due?
Okay. No. Okay. Research paper. Okay. I'm sort of distracted now because even though I set it up, the blackboard is not where it belongs. Okay. I can see it. Let me go back here to screen share. Yeah. Okay. Now, to answer your question, the research paper, and I've been telling you this all term, is due today. The last day of class is due today. Okay, now I'll give you, normally if we were in class, it would be bring it to class, and that would be it. Okay, anything after class. Because we're virtual, I'll give you till 11:59 this evening, and before you start losing points. If I get it tomorrow, or the next day, or next week, you will lose points from what you would get today. So yeah, it's due today. Always has been. In the syllabus, it's due the last day of class. Okay, and today is the last day of class. But I'll take it anytime. It's just, you'll lose a point or so anything after today. Okay? Is that your question? Okay. At least one full page of text. And I used the example before back at the first of the term. If you start typing, if you have a header or whatever you have at the top, and you start typing, say, right here, and you type, it will need to go on that page, and then on the second piece of paper, come down at least that far. That's one page of text. That's the minimum. I suggest you try to shoot for 1 to 2 pages. If you want to go over, no penalty for going over. But if it's too short, you do get penalized. Okay? It's all in the instructions, yeah, for that I did at the first of the term. They're out there on YouTube videos. They're out there on their, and every week it says research paper instructions, see week 1, and it's there. Okay. Good questions though. Excellent questions. All right, let me move these toolbars around because they are always in the way. And I'm going to start the whiteboard even though I don't need it right now, but just so I can move it around and not break up class doing it, which I'm breaking up class now doing it, but it seems to be a bit better to do it up front than in the middle of your thought process. And I'm going to scoot y'all a little bit to the right so you don't block any more white paper than necessary. Okay. Any other questions before we get started?
Is it MLA format?
Okay, that's also in the instructions. You can use any format you want to. MLA, I figured everybody knew, but if you have another format you're used to writing in and you like it, go for it, but just be consistent. So use the same format throughout your paper. Okay? I don't care which format you use, but be consistent. So if you like APA, fine, I don't care. Okay? So, but any format, but if you're not consistent with it, that will lose you points too. Did that answer your question?
Yes, sir. Thank you.
All right, good deal. All right. Okay. Any other questions before we get going? On the ambiguous case, okay? And if you remember before, and I don't know why this block is here, is that messing up your view? Please move this window away from the shared application. I don't know why Zoom, I guess it is, does that. It's probably because Blackboard is an awkward package to work with. I don't know. But here's the ambiguous case. Remember we talked about the law of sines works anytime you have 2 sides and 1 angle. Okay? Now, that could be side-side angle like this one, and we always spell it this way. It could be, oh, okay, sorry. I'm sorry, I said that wrong. Yeah, no, I said it wrong. Anytime you have 2 angles in one side, that could be side angle side or side angle or whatever the other one is that they call it. anytime you have two angles one side, you can use the law of sines. Now, you can use it if you have side-side angle. Now, what that means is the angle and the opposite side you both know. The angle here, the opposite side here. If you know both of those, you can always use the law of sines. However, that situation can be sometimes ambiguous. And that's what we're going to talk about to start with today. Okay? In example 1, we saw that two angles on one side determines a unique triangle. Absolutely. However, if two sides and one opposite angle are given, then you may have three possible situations. It may be there's no such triangle, and we'll show how that could be. It could be there's one and only one triangle, and we'll show a couple of examples of that. Or it could be that there's two distinct triangles may satisfy those conditions. And if so, that's what they call the ambiguous case. You don't know which one it is. So let's see how that works. Okay, now what we know is an angle here and two sides, one of them being an opposite side. Now, on the surface, you would say law of sines should work. And if it works, it will work, okay? But notice here, if this side here is not long enough to reach down to the bottom of that angle, you can't do it. There is no triangle that will fit that bill, okay? The necessary condition is A has to be, no, I'm sorry. Let me rephrase that. For it not to work, for there to be nothing that works there, that's if A is less than H. Now, I don't know if you can read that. If A is shorter than H, where H is B sine A, remember we did that from before. If that's your B sine A, that's what, when that A is your capital A, your angle here. If that value for for H is larger than A, there's no way you'll get a triangle out of it. This line is up here swinging around, never reaching the baseline. Okay? Now, if that A is exactly equal to H, you have a right triangle. Okay? You don't even need the law of sines, but the law of sines would still work. You don't need it. You have everything you have from your right triangle trick. Okay? Now, both of these and the next two also are when your A is an acute angle. Okay. Now, if A is greater than B, okay, that means it's got to be greater than H because H is B sine A, okay. So if A is greater than B, no way it's not going to work. That will always, always work. If A is greater than or equal to B, you're going to have one possible triangle. And that will be, you'll use the law of sines to get that one. This one where it's a right angle, where A is equal to H, that one you don't even need the law of sines. If A is less than H, no way you're ever going to have a triangle out of that. Now, here is where the problem runs. If A is somewhere between H and B, if H is less than A, if A is greater than H, you're always going to have a triangle. If it's greater than B, you'll always have exactly one triangle. But if it's in between H and B, you could have a triangle out here or a triangle here. You see that A is sort of swinging in the wind here. Okay? If it touches here, you have one right triangle. If A is greater than B, you only have one acute triangle. Okay? But if A is between H and B, you could have a triangle here with an obtuse angle here, or you could have a triangle out here with three acute angles. Now, what if your A is obtuse? Big old angle there. Well, if that A is less than or equal to B, not going to form a triangle because that A would be flat into B, not going to form a triangle. Okay? If the A is greater than B, you'll always have a triangle. Always. Same thing here. A greater than or equal to B, always have a triangle. A greater than B here, always have a triangle. If A is equal to B with an obtuse angle, then this is going to land flat on top of B and not form a triangle. Okay. Now, do you have to memorize these cases? No. You see what happens when you work your law of sines. And that's what we're going to do next. Example 3 is going to be, they tell you, I wish they hadn't told you, and by the way, we always do this SSA and not the other way. Okay, never mind. Now, for a triangle, in this figure here, your little a is 22 inches. Your little b is 12 inches. And your angle A is 42 degrees. Find the remaining side and angles. Okay? Now, number 1, you know it's got to work because A is greater than B. All it has to be is greater than or equal to B. This A is greater than B. There's no way this is going to be ambiguous. It's going to work. Okay. Now, how does it work? I'm sorry, this rectangle in the middle. Can y'all see that? Please move this window. Or do you just see a black box there? Or do you see anything? Right where my cursor had been.
Going away now.
It's going away. I'm afraid of that. I can't make that stop. I don't know why it did it, but it started doing it and it won't stop. Okay? So I'll pause when it's too dark for you to see. I also need a little bit of caffeine and sugar because I'm running out of energy. And unfortunately, since I didn't have time between my 2 classes, I didn't have a chance to go out and get another one, so I'm out of caffeine and sugar. So I'm going to have to hang it up now. Okay, so, goodness gracious. Okay, so the law of sines will work. Why will it work? Because you have an angle and you know the opposite side. And the opposite side is greater than the B. A is greater than B, so it's going to work. So let me get my pen and pad here, and let's go to town. You deal with what you got, okay? And I'm going to try to write in places that this thing. You can see inside this gold rectangle, can't you? That's not being blocked, is it? Where? The pen has been so squirrely today. You see this gold box? You can read the stuff inside of it, right? Yes or no?
Yes.
Okay, whether it's fading or not. Okay, so let's set it up. I like to do little a over sine A. This is law of sines, deals with those ratios. We can't do a thing with C's yet because we don't know capital C, we don't know little c. So forget about that. We do know little b. So we'll do b over sine b. Now we don't know angle b, but we know the other 3 things. We can solve that using our proportion. Okay? So what we're looking for is sine b. So sine b is equal to the product we know. That would be b sine A divided by the thing that we do know here, A. Okay? Now, how the book does it is sine A over A times B. And that works too, you know, however you want to set it up. So let's plug and chug and see what we get. Our little b is 12 inches. I'll leave off the units for now. Times the sine of 42 degrees. And divide that by our 22 inches. I can put in the inches, okay? Because guess what? they're going to divide out. Okay, so it didn't hurt to put them in there. You lose them anyway. All right, let me get my handy dandy calculator, which is my telephone. When I was growing up, that would have been the craziest thing I ever heard. You can't use a telephone as a calculator. Well, yeah, you can now. Okay, pull up the calculator and turn it sideways to get scientific mode. And I think I'll start with, okay, I need to be in degree mode. And on this one, if the mode is usually up here, if you don't see anything, you're in degree mode. The RAD down here, if you press that, you would become in radian mode. So this is sort of a little hard to, you have to know what you're looking for, and that's what you're looking for. So let's do 42 in degree mode, do a sine, multiply that by 12, you don't have to do it in this order, and divide that by 22. Okay, now that gives you a decimal number. It better give you a decimal number. It better be a decimal number between -1 and 1. If it isn't between -1 and 1, you've either done something wrong or there's no solution, because the sign of B has got to be between that. Well, that just gives you what sine of B is. How do you get B? Well, on this calculator, and on many of them, there will be a key over here somewhere that says second. And I can't see it backwards. There it is. Okay, you see the second right here? Press that key. I can't do it backwards. Okay, and now if you'll notice down here, what used to be sine, cosine, and tangent is now inverse sine, inverse cosine, and inverse tangent. That's what the second key does for you. So we'll now press an inverse sine. We're still in degree mode on that, and that tells us our angle for B is 21 degrees. Okay, now the book, I'm sure, is going to use a lot more decimal points than that, but 21 degrees. Now, does that make sense? Well, yes, it does, because the side A was considerably longer than side B, so you would think that angle A would be considerably larger than angle B, and it is. But we still don't have anything to do with that ratio of C and little c. Are we stuck? Can we not solve this? Or what could we do? Once you know two angles in a triangle, you know the third one. Because the sum of these, 63, subtract from 180. And you get C to be, if I can wait till that box moves out of the way, please move out of the way, I get it to be something around 117 degrees. Now the book will have a lot more decimals than that. Once you have that, you can go back to the angles inside that you know, and I'll do it up here. 22 is to the sine of 42. That's the one they gave us. That's the one I know is absolutely correct. Okay. That's equal to little c, which we don't know, over the sine of capital C, which is now 117. Or at least that's what I figured it to be. Yeah, in the book they have 116.59. They rounded differently, unrealistically, not considering significant digits. They will get a more precise answer, but it's going to be close enough. So, to get what you're looking for, the C, have it the product that you know, 22 times the sine of 117, divided by the thing you don't know, which is, the multiplier of the thing you don't know, sine of 42 degrees. Okay, We know what that is, but we didn't know the C that goes with it. Okay, so I've got the 117 up there. I'm going to do the sign of that, so I've got to get off my second thing and go back to sign, and I'm still in degree mode, and I can't get it to, well, for some reason it's not responding. Okay, let me start over, start completely over. 22, and it doesn't matter which order you do this, times 117 sine, that time it responded, and divide that by 42 sine equal, I get C to be 29, yeah, C is approximately equal to 29. Now I didn't put all the extra decimals they do, and that would be inches because your others are in inches. And we know that C is the largest angle. Capital C is the largest angle, so little c should be the largest side. Sure enough, it's larger than A and larger than B. So I feel pretty good about it, sort of warm and fuzzy, but let's see how the book did. They said 29.4 inches. 29 is close enough. Since they only gave you this in 12 inches, that's in 22 inches. Hey, where did they get those extra 2 decimal places for C? Not legitimately, anyway. Any questions on example 3? Okay. As after every example, there is a checkpoint. Please do the checkpoints. All right. Well, let's see how they did it. Okay. I forgot that. By the law of sines, you have the ratio you know is sine A over A, and they put the signs on top. I don't care where you put them, but be consistent. If you put the sign on top here, put the sign on top there. The ratios, proportions will work that way every time. Okay, so the ratio you know is sine A over A. The half of the ratio you know, you didn't know the capital B, but you did know little b, so you write this one and you solve for sine of capital B. So that's what they do next, and they multiply, since this is what they're solving for, multiply both sides by b. That's how they do it. And that's a pretty handy way, as long as you set up the problem that way, okay? But you have to know ahead of time which way you're wanting to solve the problem. And if you want to do that, you certainly can, okay? And that gives you your form. Now you fill in your numbers, and the numbers are 12 times sine of 42 degrees divided by 22, what little a is, okay? Be sure you're in degree mode, and if you are, do the calculations, and they just went right to the answer. You would get sine of B being a decimal number less than 1, and then you do the inverse sine of that to get what B is, and that gave you, and there's no reason to put the 0.41. 21 degrees would be perfectly adequate. Your original problem only listed that to the nearest degree. How in the world can you get hundredths of a degree out of that? This is a math author. He's not a physicist. Okay. Now that you know that, the next thing, once you get that second angle of a three-angle triangle, you can always calculate the third one, adding these two together, subtracting from 180, and again, see, it's ridiculous to have those decimals there. That gives you 116.59 degrees, which I just rounded to 117. Since this was only 3 digits, that's 2. That I rounded to 2. I'll let you get by with 3 here. But not 5, okay? You have no justification for 5 significant digits, okay? Now that you have that, you can do the remaining side and see they keep flipping their things over and over, so you wind up doing the best. If you just write it one way and just remember the numerator of your answer is the product you know, and the denominator is the part of the product you don't know, the part you do know of the product you don't know. Okay, well here we don't know the C, so it would be A times sine C, since we now know what sine C is, or C is, divided by sine A. I mean divided by sine A. And that's what we got here. They like to say A over sine A, which is fine, times sine C. Okay, and when you plug in those, 22 is A, sine of 42 is that, sine C, to me, 117, no justification for 2 more extra digits there, and you get 29 inches. They got 29.40, no justification for to the nearest hundredth there when you had your original problem to the nearest unit, 12 and 22. Where do they get those justification for 2 more decimal places? You don't. Okay, so that's example 3. The simple one, the one that works. Okay, so what do they do next? They jump to area of an oblique triangle, leaving you having to figure out how to do example 4 and 5, which are cases that you don't have a unique solution. So let's us do examples 4 and 5. So let's take the screen sharing back to the whiteboard, which hopefully will still be in good order. It is. Okay, I was hoping that box would go away, but it hasn't. Now, it says show that there is no triangle for which little a, if the pen would move, the pen has been doing such strange things all day. There, it finally moved. Okay, A is equal to 15 feet, and it's not writing well at all now. 15 feet. B is equal to 25 feet. And the angle between them, A, is 85 degrees. Now, after you sort of get used to playing around with these things and figuring out how they work, you would look at that and say, no way that's going to work. And here's why. Look at this angle here. 85 degrees, that's almost a right angle. Okay, that's going to be your biggest angle in this triangle, unless I'm sorely mistaken. I guess you could have one bigger angle, but that's going to be a weird looking thing. But for an 85, that to be one of your angles, oh yeah, okay, think about this. Let's subtract 85 from 180. And that would be 95, right? That means the sum of your other 2 angles is 95. Now, if one of those was 5 degrees and the other one 90 degrees or something like that, yeah, you could have a triangle like that, with this side being the side opposite this one being the bigger side. But the thing is, if that was your B, it's not going to be that much bigger than A, because these angles are so close together that these numbers would have to be close together. Now, you don't have to go through all that. Just let the law of sines take care of it for you. But that's why you can look at this and say, there's no way that's going to work. Because for A to be that big of an angle, little a cannot be that short of a side. Not that much shorter than B. No way. They're either going to be very close to the same size or A is going to be longer than B. So that lets you know. Now you could do your H, which is B sine A, and you'll show that it's not. In fact, that's what they do. They say, let's look at, oh wait, here's Courtney. He must have gotten bumped out and come back. So I'm glad he's back. Already have him present. Okay? All right, welcome back, Courtney. Okay, so here's what they're going to do. They're going to calculate what the H is. H is equal to B sine A. And that would be 25 feet times the sine. The pen is not writing well at all today, of 85 degrees. And I'll tell you, that's going to be a big number. Not going to be as big as 25, but it's going to be a pretty good sized number. So let's get my handy dandy calculator down here. Get back to calculator mode. Okay, turn it sideways so it'll get to scientific calculator mode, and do 25, be sure you're in degree mode, I am, times 85 sine. I have to do it backwards like that. You see, the sine of 85 is 0.996, awfully close to 1. So the H here is going to be awfully close to 25. Let's see what it is. Equal 24.9. Okay, now this time I will actually put that down. 24.9. Okay, feet. If I rounded that, that would say 25. So I'm going to put down the 24.9, which indicates A is way less than H. And if A is less than H, no way you're going to get a triangle out of it. Now I think that's all they did. Well, actually they did it the other way. And this is fine too. They pretended they didn't check it. Okay? So what they said, well, if I have a triangle like this, I know that little a over sine of capital A has got to be little b over sine of capital B, right? That makes sense. That's the law of sines. We know this, 15 feet over the sine of 85. This is a ridiculous way to do it, but you can. And just to let you see what happens, is equal to little b that we know is 25 feet. I was going to put a dash there. Okay, over sine of B. We haven't even drawn the picture of the triangle, which is sort of good because it wouldn't work. So sine of B, the thing we don't know, is going to be the product of the thing we do know, 25 feet times the sine of 85. Yeah, this sorry thing. Divided by the other piece of this, which is 15. Okay, and notice the feet go out anyway. That's why it doesn't matter where you carry them around or not. So let's do it and see what we get. 25 times the sine of 85 divided by 15, and that gives you sine of B is equal to 1.66 approximately. Is there anything wrong with that picture? The sine of an angle is never, ever, ever, ever greater than 1. Sines are always between -1 and +1. And to have a triangle, it can't even be +1. Okay, it can't be, because then that would be the same length, you know, same angle, and that would be a 90 degree. You can't have a triangle with one, I'm sorry, the other angle can't be. So anyway, cannot work. No solution. When you see something like this, no solution. Now, if you don't believe that, then take your calculator, do a second there, and do an inverse sign. And what do you get? Error. Okay? If you wind up doing it that way, get an error, you can almost say either I've done something dumb or there's no solution. Okay? In this case, it's no solution. I did something dumb by not catching that at the time. Okay. How are we doing? Okay. Let's move on. There's a checkpoint right after example 4. Let's move on to example 5. Oh, Kelly must have got bumped out and come back in. So she's back. She's already in the book as being here. Let me make sure. Yep. Okay. Now, example 5. Now this one's a long example. We probably aren't going to finish it, but let's at least get started. And they tell you up front you're going to get 2 triangles. What we have here is A is equal to 12 meters. They keep getting longer and longer and longer. Okay. B is 31 meters. Okay. Now just looking at those 2 numbers, I would say right off the top, hey, no guarantee this is only going to be one unique solution, because the guarantee for that would be A being greater than B. If A is greater than B, you know you got one and only one solution. Here the B is significantly larger than A, so I'm expecting either have no solution like we did in the last case, or you might possibly have 2 solutions. Let's see what we've got. Your A here, capital A, the angle A, is 20.50 degrees. Now, since they gave you, since they gave you 4 digits on your decimals, we can have 4 digits on the decimals. But I cannot see why you can have any more than 2 digits on your sides. So that's going to be my argument later, but we'll go with it. Well, here's the issue. And there's nothing to alert you to the thing except to go back and do your those tests that they gave you at the very beginning. So this law of sines would be A over sine A is equal to B over sine B. Okay, we don't know capital B. We know the other 3, so that's your law of sines. So let's plug in the numbers. 12 over sine of 20.50. I really appreciate they gave me such a long number, right? 20.50 degrees is equal to B, which is 31. You could write your meters down if you wanted to, but you just got to make sure they're the same units. They are. They'll disappear. Over sine of B, which we don't know. That's what we're looking for, capital B. So what we have here is that sine B is equal to the product that you know, 31, you could write meters if you wanted to, times the sine of 20.50, they're very specific here, 4 decimal places, degree, over 12. The half of your product here that you do know. And if you put meters here, the meters cancel out there, so you don't have to. So pull out the handy dandy calculator, see what you get. I'll turn it sideways to get it in scientific mode. 31 times, I have to enter the angle first, 20 0.5. I don't need the extra 0, but my point did not register. There it did. 0.5. Take the sine of that and divide that answer by 12. And I get a number that's 0.9047, and it goes on forever. I'm going to stop writing there. Okay, you could write as many digits as you wanted to. Okay, now we'll take an inverse sign to see what that gives us. So I do the second key and then do the inverse sign, and I get 64.78 degrees. Okay, so capital B is 64.78 degrees. Okay, now here's the issue, and there's nothing here that gives it away that you do have an issue, except for this. That sine being 0.9, okay, 64 is a pretty good size angle here, but remember with your sine, the reference angle for this one is the reference angle. If you had the reference angle in the second quadrant, it would be the same value. So there is another angle that has that. A sine of that angle would be 0.9047, and that would be just over here. And what that would be, subtract that from 90. This is your reference angle, and subtract that from 180. So let's do that. Change the sign of that to a minus and add to that 180 degrees. And that gave me another B. I'm going to call this B little, the smaller angle, and the B big would be 115.22. Since we're having two decimals there, let me make sure I'm doing this right. 64.78 or 115.22. Got it. Okay. Now, there's nothing on the surface that tells you that's a possibility. Like I said, the thing to watch for is when you have a fairly large sine here, which produces a reasonably large angle here, that could produce another one here that would also work. Okay, well, since you have two angles you have to deal with, you have a bunch more calculations you need to make. The first one being, if your capital B, the little capital B, would produce a capital C, that would have to be a big capital C then. But I'm going to keep the subscript little, but of course this is going to be, and this is going to be 180 degrees. That's your total angle, minus the 20.50. Sorry, I'm running out of time, and yeah, I have run out of time. Sorry about that. Okay, we're going to have to hold it there. Okay, so you can see, and since we didn't have a chance to finish this, I'm going to hold it up for you to see. They did finish theirs. Okay, there it is. Your A's, the B's, the capital A, they're the same in both of those triangles. The difference being that angle B, there's a little angle B, an acute angle B, and an obtuse angle B. That's what gives you two different triangles. So you have to do all your calculations from that point on. Your acute angle B will give you an acute angle C, a fairly small angle. Your obtuse angle B is going to give you a very small acute angle C. Okay, let's see. No, I said that backwards. Yeah. Okay. The acute angle B will give you another acute angle C, but it'll be a reasonable size. The obtuse angle B will make your little c very, very small. Okay. Happens not to be as small as A, but it does appear to be a pretty good. And actually, I said it would guarantee, the first one would guarantee you an acute angle. It's not. It could be obtuse too, because A and B are both small angles, 64 and 20.5. That adds up to be less than 90. So your first angle C is going to be an obtuse angle. It doesn't have to be, but it could be. Your second one will be an acute angle. In fact, now that I think about it, yeah, one's going to be obtuse and one's going to be acute. I hadn't thought of that before, but that's true. All right, if you want to do a few more exercises here, you can do any of the odds 5 through 21. They should all be at Calc Chat. 11's at Calc View. 23 through 31, they should all be at Calc Chat. 29's at Calc View. 33 or 35, they should both be at Calc Chat. And that's as far as we got. So, what I'm going to do now is going to break for just a moment here as I pull up something else. I'm in the wrong place. There it is. Okay. Okay. I don't know. Maybe I didn't teach this. Here is what your final is going to look like. Okay. You can't see it. Hold on a moment. I'll put the new share up there. Okay. Now, I won't be able to get this to you until sometime between 1 and 5, hopefully. Okay? Question 1 and 2 and 3 and 4 I think will all come from Chapter 4. Okay? 5, 6, 7. I'm going to have to move y'all out of the way for a moment. Okay. 5, 6, and 7 will come from Chapter 5. Okay. 8 comes from what we've done in Chapter 9. So you can do 8. However, 9 and 10 are beyond what we got done. So therefore, 9 and 10 will be optional. If you want to do them and get them right, you'll get bonus points. If you want to leave them blank, they don't cost you. If you want to do them and get them wrong, they don't cost you. So it's up to you whether you do 9 and 10. But everybody does 1 through 8, and you'll see you have, now I have to move y'all again. Okay, hold on. Hold on to your seats, you're getting moved. Okay. You see here 1 through 8, you have quite a few blanks here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they're not going to count enormously a lot, but they will count significantly. But you have 13 possible answers, so they're not going to count really heavily. So you can still miss a few. So there's your final. I'll give it to you sometime today between 1 and 3, hopefully. Hopefully I can get it done. I've got to take a copy of it down and do a scan of it on an Adobe Scan to get it back so I can send it to you, because this is in WordPerfect, and I bet you none of you have WordPerfect that you could read it. So I'll have to do this in Adobe. That's going to take me a little longer to do. Not a long time, but it will take a little more. So sometime between 1 and 3, hopefully I'll be able to get this out there to you. It will be under Blackboard Messages and possibly under the Final Exam tab on the Blackboard content page. Okay? Any questions? Okay? Now, did want to say this. As I said before, this is my last full day of teaching, period. Okay? And this is one of my larger trig classes I think I've ever had. I think some of you got moved over from another class, and this has been one of my best classes that I've ever had, trig classes. I think, I haven't checked this for sure, I believe your attendance is just about the best of any class I've had all term. There may have been one that only had like 3 or 4 students in it that got a little better, but of big classes, you're way, way ahead of the others. So I really appreciate that. Y'all have been a great class. I wish I had gotten to know you personally. I didn't. I got to see a few of your pictures, so I sort of imagine what you're like, but I don't know you. Sorry about that, but I do wish you the very best in your future endeavors. At Lawson and after Lawson. You know how to get in touch with me at least through the end of January. Now, someone has a microphone on. I believe it may be Sharika. But you know how to get in touch with me. If you need me for anything, please do. Now, sometime after the 1st of February, I'll probably lose my Lawson email. So if you need or want to maintain contact in case you need help in a calculus class or something like that, be sure you contact me and I'll give you my personal email. I should know it now, but I never use it, so I'm not absolutely certain I give it to you correctly. I've been using only my Lawson email, even though my wife set me up a Gmail account. I never use it except when I have to, and I can't remember now exactly what it is. So if you do want to do that, I'm certainly happy to be available, because once I retire, I have plenty of time, supposedly. Okay. Any questions? All right.
I have one.
Okay, what is it?
Do you have a spot for us to turn in the final in Blackboard yet?
Okay. I think I just said there is the final exam place. It's after the weekly activity thing. There is a tab. If you want me to, I think I can go to it pretty quickly. Okay. Goodness gracious. Sharika, I think your phone is on. Okay.
I had a question.
Okay, what is it? Okay, I'm going to have to.
Homework. Can we still turn? Is homework for a grade?
Okay, let me first answer Matthew's. Okay, you can't see this yet, but I'm going to do a new share now. This is taking longer than I thought it would. Okay, do you see my content page here? Yay? Yes? Okay, go down at the end and you see here exams, midterm, and final. Click on that. Okay, something opens up here, and when it gets open, oh man, I didn't get this done. So maybe it won't be, okay? But what I'm going to do, I'm going to get rid of this and this and this and this. And here under final exam, let me just see if it's going to let me do it. Yes, I'll post it here, and if you want to submit it here, you can. I don't have it set up yet. I'll try to get that done after class, well, between 1 and 3 also. Or you can go to Blackboard Messages and send it that way. Now I've got to move y'all again. Hold on to your horses. In fact, I'm going to move y'all over here. Okay. You can go to Blackboard Messages here and turn it in there. Or you can turn it in by email. So there will be a place there under exams, midterm, and final. There was no midterm. All of them were midterms. And it's right there. I will take off the hidden from students. I don't know why they do that. I think I do know why they do it. it'll say final exam, and that's where I'll put the final. It'll also be under messages, and it'll also, that's where you can submit it. You can also submit it under messages or as an email attachment, either one. Okay, now Sharika's question. Homework, does it count as a grade? Not as a grade. If you notice on homework, it's 0 points. But what I did say at the first of the term, and it's still true, if at the end of the term you happen to be, say, a 89.4, that would normally be a B, and it would be a B. But if I look at your homework in your book, in my book, this is the wrong book. No, that's the right one. I won't show names or anything here. But if I see that the majority of your weeks you did turn in homework, or then I'll bump it up that fraction of a point to give you an A. So if you had an 87.3, that's not going to help you any, okay? It helped you because you did your homework, and that probably got you an 87. But if you did the majority of the homeworks and you come out right on the borderline, but not quite high enough to get bumped up a grade, that homework will bump you up that fraction of a point. So it's only good for a fraction of your average, okay? Some fraction less than 0.5. So if you had an 80, like I said, 89.4, yeah, that would bump you up, no problem. Give you a 90, you get an A. So does that answer your question?
So they still be turned in?
It can be turned in, but please get it in sooner rather than later. If you are still turning it in when I'm already averaged the grades, I'm not going to go back. When I've already submitted the grades, I can't go back and change them. So you have until now, and when grades are due in, well, you don't know when I'm going to submit them. Yeah, but get it in soon. Very soon. If you're going to do that, get it in soon. And I may not have, and what I'll do, anyone who's turned it in before will know this too. I'll say, I've noted the receipt of this work, put it in my grade book. I'll put it on Blackboard as soon as I can. And it'll be a 0 on Blackboard, so there's no points for it, but it'll indicate that you did submit it. And I'll have it in my grade book as well. Okay. Is that good enough? All right. Any other questions? Yeah. Was there another question? Okay. If there's no more questions, I'm going to stop the sharing. And thanks for being a good class. I've enjoyed having you. I wish I'd have gotten to know you in person, but that wasn't to be. And the main thing from now on is take care of yourself, take care of your family, practice, masking, social distancing, do all that. The numbers are going through the roof. This is a really bad time, and it's a terrible time to be going back to campus. But if you have to do it, you have to do it. But please be careful. Please be careful. Take care, folks, and I'll be looking for your papers, okay? And you'll be looking for your grades, I'm sure. Okay. Thank you. Bye-bye. Goodness gracious.